Hello everyone, in this session we are going to talk about a very useful structure, the sparse matrix. It's extremely important in areas like machine learning, graphics and network analysis, especially when working with large but mostly empty data. So, what is a sparse matrix? A sparse matrix is a matrix where most of the elements are zero. This is different from a dense matrix where most elements are non-zero. Using a sparse matrix allows us to save both memory and computation time. Let's look at an example. Here only two elements are non-zero, the rest are zeros. Instead of wasting space storing all the zeros, we focus only on what's meaningful. So, why are sparse matrices important? They save memory space by not storing zero values. They reduce computation time, especially in operations like matrix multiplication. They allow us to efficiently handle large data sets, which are common in machine learning, image processing, and graph algorithms. There are a few ways to represent sparse matrices. The first one is triplet form, the second one is compressed sparse row, the third one is compressed sparse column. In this lecture, we will focus on the triplet format, which is simplest and easier to understand. In the triplet representation, we only store the non-zero values along with their rows and column position. The format look like this: row, column and values. Let's take this matrix as an example: 0, 0, 3, 0, 0, 0 and 0, 9, 0. The triplet representation would be 0, 2, 3, 2, 1, 9. So instead of storing all 9 values, we only store 2 entries and saving memory. Here's how we convert a regular matrix to sparse form. First, count the number of non-zero elements. Second, create a new array which size is equals to number of non-zero element cross 3. And the third is, for each non-zero element, store its rows, column and values. This process is simple but powerful, especially when dealing with use matrices which is full of zeros. So, what are the benefits of using sparse matrices? The first one is saves memory, especially for large sparse dataset. Second, faster computation like matrix operation or searching. The third one is easier to store and transmit, which is useful in machine learning, graph theory, and data storage system. That's all for today's session on sparse matrices. We have now seen what they are, how they work, and why they are so useful in the real world. And with this lecture, we officially complete our unit on arrays, including 1D array, 2D array, multidimensional arrays, arrays with functions, array of pointers, and sparse matrices. Thank you for sticking through the unit, and I hope you are now feel confident working with arrays at all levels.